Hi, good morning, everyone. My name is Varun, and this week we're going to be looking at how we can deploy the Docker images that we developed last week onto AWS Fargate. So, just to give you a quick overview of what we have done so far, so we've got a Spring Boot app and also a MySQL database, and the requirement was to make it talk to each other. So for this, we use the Docker Compose solution. So Docker Compose is something provided by Docker, which acts as an orchestration engine to orchestrate our containers in one network. So as we saw last week, we've got a few environment variables that we are passing to the MySQL Docker container, and also a few environment variables we are passing to the Spring Boot application. So if you remember, one of the requirements was that the database has to be up before bringing up the Spring Boot app. So we used an external dependency on the wait host, which would make sure that the database is always up and running before bringing up the Spring Boot application. So, so last week, this orchestrated solution was actually running on your local Docker. So this time we've got to make sure that it runs on AWS Fargate. AWS Fargate is a managed solution provided by AWS. So it'll make sure that the containers are scaled and containers are shrunk and all the other things. AWS will make sure that they'll do it for you. So there are two types of AWS ECS options available for you. So we've got AWS Fargate and the type is AWS EC2 as well. For this lab, we're going to be using AWS Fargate. So we don't have to manage auto scaling and scaling up, scaling down instances and stuff like that. So AWS is going to take care of this for you. So we've got, in order to accomplish this, we've got to, uh, you know, uh, make some changes to the compose file that we wrote last week. So we've got to provide logging drivers and just in case if things go wrong and stuff like that. So let's have a look at what are the steps involved in accomplishing that. So in AWS, it expects a couple of files provided along with the compose in order to deploy this compose file that we have. So let's have a look at what needs to be done in a nutshell. So there are some steps involved in getting this up and running. So first, you've got to make sure that your code is compatible uh, with the existing code that you have written. So we've got to make some modifications, and then as a part of deploying this to AWS, there are some other AWS concepts that we would be covering in this lecture. So we've got to create an IAM role. IAM role is nothing but providing authentication and authorization for the resources on AWS. You've got to create a role as well to make sure that the CLI, that is the command line interface that we are using, uh, is uh, is able to assume the role to create resources on your behalf. And we've got to install the AWS CLI. So AWS CLI is what we are going to be using to make calls to AWS on your behalf. So we would be providing something like an access key to the CLI so that it'll make calls and create resources on your behalf. So you've got to configure the CLI, provide it a cluster name. So we're going to be creating a cluster as well as a part of AWS Fargate. Uh, so we have to create security groups. Security groups are nothing but how you can control access to your EC2 instances, like inbound rules and outbound rules. For example, if you want your database subnet to be not accessible to the public, you would set an inbound rule allowing no traffic. For example, the web server should always be allowed on port 80. So you would need to allow the inbound rule so that you can get to the web server. And after we have done all these steps, we have to initiate a command which will bring up the application on AWS. So yeah, let's get back to the code and see what needs to be done to make this up and running. So for this compose file, AWS, so it doesn't have any run parameters. So run parameters is something that AWS Fargate expects. For example, how many CPU or RAM needs to be provided to get this application up and running. So we don't have that currently in this application. For example, when you were running this application locally on Docker, we don't need to provide any of that because you uh, are the owner of the system, and then you can provision resources as needed. But that's not the case in AWS Fargate. You have to specify the CPU and memory limit and all the other parameters that it requires. So let's have a look at what that is. So like I said, AWS expects a file called ecsparams.yaml file that you need to provide. Uh, let's create that file in here. So in the root of the project, the same place where we have the Docker file and Docker Compose file, you have to create a new file. I'm just going to create the new file and name it ECS params.yaml file. So remember, this needs to be the same name as what we are entering here because that's what AWS expects you to provide. So I'm going to create this file, and yeah, I'm just going to click cancel. It's asking me to add it to the Git. No thanks. And I have copied the ECS params.yaml file in here. So let's have a look at what that is. It's specifying a version and uh, and task definitions. So AWS has the concept of task definition. So every image or container that you deploy as a part of the task definition is going to be deployed onto a single instance on AWS. So that means that the instances or the services inside the task definition can talk to each other. So via the local host or the loopback address, that is 127.0.0.1. So remember in the last week, in order to accomplish that, we use the network because here we are making sure that the Spring Boot JPA app and the MySQL Docker container are in the same network. So when you're running this in AWS, you don't actually have to do that because in task definition, if you use a task definition and if you've got two services in here, it's going to make sure that it's in the same machine. So you don't have to do that. Uh, so And you also have to provide certain other environment variables and run parameters. So let's have a look at what that is. So in order to execute commands on your behalf, ECS CLI would also expect a task execution role to be provided. So this is something that you would be creating in an IAM role. Let's have a look at that later. And also the task limit. So this is the maximum memory limit that will be allocated to the container. So uh, this is to basically ensure to keep a check on the resources because we are going to be paying for all of this. Let's keep that in mind as well. Uh, and CPU limit is 256 processing units. And also some of the run parameters that is required. So when you're creating the resources, it will be created in a VPC. VPC is nothing but an isolated section of the cloud that is a virtual private cloud. And you've got two subnets and a security group. The subnet is what will need to be provided when you create a cluster. So when you create a cluster using the Amazon CLI, it will span across two subnets. So two subnets in different availability zones. So this is to make sure that your cluster is highly available. So the parameters in here are going to be what is coming out of the cluster create command. Let's have a look at that later. And also the security groups. So this is really important. So this is what will make sure that your instances can talk to each other. For example, in our application, we've got a Spring Boot app which will listen on port 8087, right? So if you want to expose this and if you want to hit it from your local host, you've got to make sure that your security group allows port 8087 to be accessible. So you have to create a security group on AWS and provide it here. So let's have a look at that as well when we create it. And also the task placement strategy. This is really important because this will ensure that how AWS will place your containers on different machines. So we are using a bin pack strategy here, which will place the instances based on the least available memory. More information can be found out on the lecture slides. That's pretty much it. So we also have to make a few changes in the compose file as well. If you remember, so we don't need this network section when you're deploying to AWS because AWS is going to make sure that you can talk to each other through the loopback address. So let's have a look at what changes need to be done for that. So we have the docker compose.yaml file. So let's change it to reflect that. So in here, there are a few changes that we have done. So if you have a look at the MySQL Docker container section, we have added a logging driver. So this is the driver provided by AWS so that you can log what is happening inside the containers onto uh, AWS CloudFormation. So AWS CloudFormation is a service provided by AWS so that you can stream or output logs onto that, and you can query the logs and stuff like that. So it's a logging, consider this as a logging solution provided by AWS. So I have added the logging solution onto both the containers so that we know what is going on. So for example, if when we spin up the container, if our containers were to crash or come down for some unknown reason, we would need to know how it went down or what is the reason behind that. So that's why we are adding the logging driver. I would highly recommend adding this. It's going to work if you don't provide the logging driver, but again, it's really informative. And also, there are a few other changes that needs to be done as well. So if you remember, last week in the solution, we had this image which was pointing to the local Docker image, which was running on your laptop. So if you do a Docker image ls, which will show the images on your laptop, so you can have a look at this. This is the image that I'm talking about. So Spring Boot JPA, this is the image that was running on your local. So if you're running this in AWS, we would need to make sure that the AWS ECR, which is nothing but the Elastic Container Registry, would need to pull the images. It won't be able to pull the image from this local laptop, right? Because it's running in your local laptop. So we've got to provide the repository image URI. We'll have a look at that later when we get to the practical part of it. And also the wait host URL. So here we had the container name last week, but we have changed it to make sure that this listens on localhost, which is nothing but the 127.0.0.1. And one of the other requirements in ECS Fargate is the host and the port mapping has to be the same. So last week we had 8080 in the container, listening on 8087 on the host. But like the requirement on AWS side, we've got to make sure that this listens in 8080. So it's not a big deal. We've got to, we will be hitting the APIs on 8080 instead of 8087 for this tutorial. And also another change that we did was to change the Spring Data Source URL. Also, we took out the container name and we put in the loopback address. So these are all the changes that was done. So after doing all these steps, you've got to build this project because we have made changes to the application.properties file. So which means that we would need to create a new jar file. So in order to do that, you have to do a Maven clean install. So this will make sure that a new jar file is created. So like I said, so this will try and run the tests, and I'm expecting this to fail because the addresses will not be available. So we have to make sure that we skip the test. So there is a command in Maven which we can use. It's -t. In fact, let's look the command up. Maven skip test. So this is the command. You have to provide the argument dmaven skip test equal to true. So let's have a look at that. So this time I'm expecting the builds to pass because we are not going to be running any tests. So as you can see, the build was a success. So we've got a new jar file. So next thing that we need to do is make sure that a new Docker image is created, because remember, ECR will need the new latest image that we have built. So in order to do that, we can use the command docker compose up, sorry, docker compose build. So up will actually run it in your local. We don't need that. We want to build the solution. So docker compose build, oh, sorry, there was an error in the command. It has to be a hyphen. So this will create a new Docker image for our Spring Boot Data JPA app. Looks like my new image was created. So so these are the prerequisites needed in the code to make sure that we can push this image. So let's get back to the pushing the image part. So we have to do a bit of CLI installation and other stuff to get this up and running. So so the first step that we need to do to get this up and running is let's have a look at the instructions. Yeah, so you've got to create an IAM user. So to do this, so let's go back to AWS. So uh, this is the AWS console. So I'm going to IAM, which is managing the users and authentication and stuff like that. So this is Identity Access Management Service provided by AWS, if you did not know. So we're gonna go to that. And so we have to make sure that we have a user which our CLI would be making calls to. So let's have a look at that. I'm just gonna go to users. I have a few users in here you might not have. So you can click on add user. So I'm just gonna give it a name, ECS lecture, programmatic access. So we are only going to be providing programmatic access, no console access, because you have to make sure that you provide only the necessary credentials that your service would need. That's a best practice from AWS. You can go to permissions, attach existing policies, and then I'm just going to give it administrative access, but you don't need to. You only need to give it the necessary permissions that it needs. Uh, so tags, I don't need any tags. ECS lecture, I'm just going to review everything, and I'm just going to create the user. So AWS is going to create the user, and this is very important. So you've got to make sure that the CLI credentials file is available. So this is the only chance that you get to download this file. If you move out of the screen, you will not be able to get the access key ID or the secret key, which we would need. So I would highly suggest you download this credentials file, because we would be using this credentials via the CLI. So I have the file downloaded. Remember, never share your access key and secret to anyone, because if they have this, if someone has your access key and secret, they can make AWS calls on your behalf, and you can get charged for stuff. So yeah, we will be changing this, deleting the user after this tutorial. So don't even bother looking this key up. That was pretty much it. So we have a new IAM user. So let's go back to IAM, see our user created. So we have the ECS lecture user created. So for the CLI, we would also need a role which the CLI would assume to interact with ECS. ECS is nothing but the Elastic Container Service. So we have to create a new role as well. So I'm just going to create a new role. So this is asking which role is going to be, the identity. So I'm just going to select Elastic Container Service. So this is a service that will be using this role. And the use case, so the use case for us is Elastic Container Service task. Allow ECS tasks to call AWS services on your behalf. So that is the one that I want. So I'm just going to click permissions, and then I need to assign a specific permission. So ECS role. Uh, so in the type of entity, so this is what we used, Elastic Container Service, and use case is Elastic Container Service task and permission. So this is what I need to look up in AWS side. Uh, Elastic ECS task execution policy. This is what is needed. So click on next. I don't need any tags again. And the role name is ECS task execution role. So here, as you can see, I have a role which I have already created before, but you can go ahead and create new role. Uh, yeah, so this role already exists. So you can name it something else, but again, I'm going to be using the same role that I have before. Yeah, so you can create the role, and if you go to the roles section, you will see the new task execution role that I've created. So this is the role that I had created before, ECS task execution role, which is the same, which has the same permissions as my task execution role. So if you remember, this is what we're going to be using in the params.yaml file. Task execution role has to map what we just created. So now we have the IAM user and the roles, which we're going to be using in our CLI. So let's have a look at what that is. ECS params. Yeah, this is the one. Yeah. So next, we will look at how we can install the ECS CLI. So if you jump over to Chrome, and if you go over to the, so let's install ECS CLI. Yeah, so let's have a look at this first link that we got. So you can, these are the instructions for Mac OS and for Windows. So choose whichever one you prefer and, continue accordingly. So for me, I'm using a Mac, so I'm going to be using this command, and you can go to your terminal and paste in this command, and it will install the CLI for you in user local bin ECS CLI. I'm not going to run this command because I have already installed the CLI, but you can go ahead. It's pretty much a simple process. Uh, and after that, you've got to so yeah, there are various ways to install the CLI and other stuff like that. So after you are done with that, the next step is to make this file executable. So you've got to uh, do a chmod change modified plus X and then make this user local CLI executable. So after installing that, you will have ECS CLI installed. So you can do an ECS CLI --v will print out the ECS CLI version in here. So if you get to this part, it's all good. But again, it's just a bare metal CLI. We don't have it configured yet. So the next step would be to configure the ECS CLI. So we've got a few commands lined up in here. So this is the ECS CLI command to make it executable. You verify the version and make sure that it is installed. And in order to configure the CLI, this is the command that we are going to be using. So it's ECS CLI configure profile. You've got to provide a profile name, and remember the access key and the secret. So this has to be what you downloaded in the file. So let's have a look at this credentials file that we downloaded. So AWS has provided an access key ID, and also the secret key access key. So this is what we are going to be using in this configure elastic CLI command. So I'm just going to copy my access key ID from here and paste it in here, and also the secret key, and paste it in here. Yeah, looks like I have the commands correct, and I'm just going to copy this and move to my console. And so yeah, let's have a look at quickly have a look at the command. So you're configuring the CLI to use the profile. So the profile name is going to be ECS lecture. Uh, Looks like I got the command a bit wrong. So there has to be a space after this, dash access key. Let's have a look at the command again, see where I messed up. Yeah, let's give it a go. And the access key is the ones provided and the secret key, and let's click enter. So we've gotten the output saved ECS CLI profile configuration on ECS save lecture. So what has happened is that AWS has configured your CLI to use the access key and the secret provided. So if you go to your home folder, you will have a directory. It'll be hidden. You've got to make sure that you can see the files if you want to have a look. So .ecs has been created. If you have a look at that, there's a credentials file already created for you by the CLI, and it will have the parameters that you provided. So yeah, that's what happened. So our looks like our CLI was configured with the user that we created. So the next step is to configure the CLI to use the cluster names provided. So next command is to configure the cluster to use the cluster name that was provided. So let's have a look at this command, ECS CLI configure dash dash cluster, and you provide a cluster name. So here our cluster name is ECS lecture, and the default launch type is Fargate, which if you remember, AWS is going to manage the servers and not us. And we are providing a default region where our cluster is going to be created. So that is US East 1, which is in North Virginia, and a config name called ECS lecture. So this is where the configuration is going to be stored for this cluster. Uh, just go ahead and click that, and you should get the output that saved ECS CLI cluster configuration ECS lecture. So let's have a look at the ECS directory again. Another file named config has been created with the cluster name ECS lecture. So this is what the CLI is going to be using to make API calls to AWS on your behalf. Let's have a look at what needs to be done after this. Looks like the CLI is configured correctly. So the next step is to create a new cluster where our containers are going to be running. So the command for that is ECS CLI up dash dash cluster and cluster config. So it should be the same cluster config that you named in the previous command. So my cluster config is ECS lecture, and the profile name is also ECS lecture. So remember, it should match the ones that you created in the previous command. Let's give it a go. So this will take a few moments. I'm just going to wait. So in the meanwhile, just gonna give you a quick explanation of what is happening behind the scenes. So this CLI is gonna make calls to AWS using the access key and secret provided, and it's gonna create a CloudFormation template and create resources on your behalf. So this will take a while, and after running this command, it should provide you the VPC ID, that is a virtual private cloud ID, and also the subnet IDs, which we will be using in this part, the subnets. Yeah, it's still in progress. It might take up to a minute or two, depending on the AWS side of things. Get a coffee or something in the meanwhile. Looks like the cluster was created and it has given me the VPC ID and also the two subnets in different availability zones. So the first thing I would do, I would copy the subnet ID, first one, onto the subnets in here, and I would copy the second subnet of my cluster in here as well. So if you have a look at this, we would also need a security group to be created, which would dictate how our instances can talk to each other, or the inbound and outbound rules. So we would need to create a new uh, security group as well. So before that, let's have a look at the cluster in the dashboard. So if you go to AWS and if you go to services, you click on ECS. ECS is Elastic Container Service. So a new cluster should appear here. So this is the lecture. This is the ECS lecture cluster that we created. As you can see, it's a Fargate cluster. Cluster state is active, and there are no services running. There are no pending tasks, no running tasks. So it's an empty cluster. It doesn't have anything running on it. So we would be running the services, our two containers in this cluster. So for that, we would need to create a security group under this VPC. So let's go to the VPC section, VPC, and let's have a look at the VPC ID that is created. So VPC ID ending in DB was created for us. Let's have a look at that in the VPC section. I have a few other VPCs in here, but you would have the default VPC and also one more. So it looks like this is the one that AWS has created. Let's have a look at that. So we're going to be creating a new security group, which provides access to the instances. So somewhere along here, there should be a security. Yeah, there you go, security groups. Security group, we have to create a new security group. I'm just going to give it EC, again, I'm just going to keep it consistent and name it ECS lecture. Allow access to the console. And this VPC has to be the one that is created. I'm just going to select the VPC that ends in DB, and I'm just going to create click. And if you click on this link, it will take you to the security group. And as you can see, it has got no inbound rules. So if you apply the security group to the container, it's not going to allow anything. So your request will not be hitting the container because it's not allowing anything. So first thing that we need to do is add some inbound rules to make sure that our instances are available. Again, I'm just going to create a custom TCP rule, which will allow pretty much everything. Uh, Again, the best practice is to allow only the ports that you would need to. But for this lecture, I'm just going to keep it simple. So this is saying that allow all TCP ports from anywhere to be accessible. I'm just going to click on save rules, and then it was saved. And you have to get the security group ID and paste it in this section. Remember, this is the security groups that is going to be applied to our instances, sorry, the containers. And that looks like it's pretty good. And also, so we've got a security group ready and a cluster created. So the next step would be to make sure that everything is good. And you can now try and deploy the solution that is created. But again, remember, we haven't pushed our uh, the new image that we are using in this compose.yaml file. So this image, right? So you've got to make sure that you push the image that we built earlier. So for that, the command for pushing is ECS push and the image name. So if you go ahead and copy this ECS CLI push Spring Boot data. So this is going to push the image to the ECR registry, Elastic Container Registry. So this is an image which is around 600 megabytes in size. So it's going to take a while. So for me, it took more than an hour, but you might have a better internet connection. It depends on that. So this will get the account ID from the CLI and it will try and push. Uh, so it will take a while. So if you go to after the image is pushed, if you go to services, ECR is nothing but Elastic Container Registry. You will be able to see an image, repository name, Spring Boot Data JPA image, and also the URI. So this is the URI that we will be using in the Spring Boot Data JPA image section. So this has to match. So after your image is pushed, it will be visible in the ECR registry. So this is what AWS will be pulling the image from Fargate. So let's try and bring this container up. So the command for that is to deploy it to the cluster. I'm going to be using, so ECS CLI compose up, create the log groups that we provided in the Docker Compose file. So this is the log group. Log group is tutorial. So it's going to create whatever's in here, and the cluster config is ECS lecture, and the profile is ECS lecture. So remember, you've got to run this command from the same place as how you would run a Docker Compose file in the same directory. I'm just going to click on run this command. So yeah, looks like I have a log group already existing. So again, looks like it's started bringing up the containers. So there is a command to see the containers. So you can use the command ECS CLI PS, which is nothing. It is similar to the uh, Docker PS command, which shows the list of running containers. So you would be able to see a couple of containers. Yeah, as you can see, our containers are coming up on Fargate, and the IP is 10.0.0.176. So this is the IP that Fargate has chosen. Let's pop back in here. It's still running. So you can run this command again to see the current status again. It's still running. Let's pop back to AWS and see the logs. So if you go to ECS, you go to ECS lectures, the cluster. So you go to tasks. So you can see our one task running. Click on that and the logs, and you can select the MySQL Docker container logs. Looks like it's come up, and you can go to Spring Boot Data JPA app. Looks like there was an issue connecting to the server, that is the MySQL. So our container would have gotten killed if you run this command again. Yeah, looks like our container was exited. Let's have a look why. So it is because it tried to uh, ping the database, and then it was not able to find a connection. So it was not able to find this port. Let's have a look why. In the ECS params, we provided the security group ID as well. Let's have a look and see VPC. Under VPC, you go to security groups, ECS lecture. Yeah, it looks like the ID is correct. SG05. Yeah, ends in D5. Inbound rules allow all TCP. Yeah, that looks correct. and the subnet corresponds to 123 and 9EE. Yep, that looks correct as well. Compose.yaml file. Yeah, we are using the ports correctly. Port mapping is all good. Application.properties is all good as well. I have saved the file. And the task execution role is, yeah, what we created. Let's give it a go. It is bringing it up. ECS lecture, task, logs. Looks like it's still not able to find our port. It will fail. Yep, as a timeout. This could be due to the security groups, I guess. So let's pop back to security groups and go to the ECS security group. So looks like we are allowing only alt TCP. So let's go back and change this to allow all traffic for IPv4 and IPv6, and let's save the rule, and let's pop back to IntelliJ, and let's run our container command again. So it's going to bring up these two containers. So this time we are allowing all traffic. It's coming up. Let's pop back to terminal and look at our running containers. Yeah, it looks like a couple of containers are running. You can run this command again and again to see the updated status, or you can pop back to Chrome. You can go to ECS and have a look at all the running containers. Go to clusters, you click on your cluster, and you click on task. You click on the running tasks that are spun up, and then as you can see, both these containers are in the pending state. You can click on logs and click on the MySQL Docker container. So it's coming up. You can click on refresh logs to see the new logs that is coming in. I think it's refreshed every 5 seconds or so. Yeah, looks like it's going well. So Our Spring Boot app will only be started after this container is up. So the Spring Boot app is going to be pinging this container every second or so to make sure that this is up and running. So if you switch back to Spring Boot data JPA image, so as you can see, it has tried many times, and then when the database was up, you can see that logs has changed to database is now available. So that is a good sign. So now the Spring Boot app is going to start. Yeah, looks like it's starting. It's coming up. So the how fast this Spring Boot app is going to start depends on how much memory and CPU you have allocated in here. So this would be the minimum to start it up in a reasonable speed. So I had to play around with these parameters a bit. Again, this is not free tier, so it'll cost you a bit. So be aware of that because we have a cluster and containers and running on that. So yeah, it's not free. Uh, so it looks like our API is up and running. So you can also see, it's another thing that I want to show you is you can see these logs in a nicely formatted manner in CloudFormation. Sorry, in CloudWatch. If you go to CloudWatch, so you remember we were passing in the log group in here. So this would be stored in CloudWatch. If you go to CloudWatch, you should have, if you go to logs, you should have a group tutorial that matches what you put in here, tutorial, and you can go here and you can view the logs. So this is the latest one. Click on that. You can see the logs in a much better format. Uh, so this is the Spring Boot app starting up. And as you can see at the last part, it says that 8080 it's available. So in order to hit this, so this is running in AWS Fargate. So the instances are not managed by you, but it's managed by AWS. So if you want to have a look at that, you've got to get the IP of the container. So you run the ECS CLI PS command. So as you can see, you've got two running containers in here with, so this is the IP that AWS has given us. So you copy the IP and you go to Postman and you paste the IP in here, and then I'm just going to initiate a GET request. So as you know, it's now freshly created. It won't have any you know Pokemons in it, so it's going to return me an empty array. That's what I'm hoping for. Looks like I've got an empty array. So let's now try and create a new Pokemon. Let's do a post. Let's provide it a name and power of test and test. I know this is not a good name, but again, just for the sake of you know getting on with it, let's send a post request. A new Pokemon should be added. Now let's try a put, which will update the existing Pokemon. You've got to provide ID in the path parameters. I'm just going to modify to 5042 and oops, 5042 and 5042. What is wrong? Oh, yeah, 5, not F, sorry. Yeah, so this should modify the existing Pokemon. Let's give it a go. Yeah, looks like it's updated. Let's try a delete as well. Yeah, just the ID should return me an empty array. Looks like our API is running up and running in Fargate. Congratulations, guys. If you look at the IP, this is actually the IP that Fargate is using. Uh, that is pretty much it for this tutorial. So you have learned tons of stuff in this tutorial. You've learned CloudWatch, IAM roles and IAM users, ECS, that is Elastic Container Service, Elastic Container Registry. This is all the cool stuff. It's pretty good. Have a look at that and let us know if you have any questions. Yeah, that's all. Thanks. Thanks, guys.